Hi class, so in this video I'm going to talk to you about limiting reactants, also known as limiting reagents by some people. So I'm going to talk to you about how do you determine what a limiting reactant is, what does it do, how do you draw it, and then how do you write a sentence about your chemical reaction. A couple of definitions you should know ahead of time. One of them is what is a limiting reactant? As you know from the activity that we've been doing in class, the item on the left side of the reaction that runs out first, and it limits the amount of product that's being made. The excess reactant, on the other hand, is the one that's left over in a chemical reaction. It doesn't determine the amount of product. Does not. Two other definitions you have to know, which we've gone over previously, but a molecule is two of the same kind of atom bonded together. For example, O2 or N2 are molecules. Now, this is not a perfect definition, but for our purposes right now, it'll do. And when different atoms are bonded together, for the purposes of this activity, we'll call it a compound. So, for example, H2O is a compound, and carbon dioxide is a compound, and sodium chloride is a compound. So, again, these are not exact definitions of these two words, but we'll get better at it as we learn more about chemical bonding. Okay, so we have this chemical reaction and it's already balanced, and so we have to fill in the appropriate words in the blanks here. So you can see that there's two hydrogens, right there, the coefficient, and hydrogen, as you can see, it's two of the same atom, so it's molecules. Reacts with, and you see that there's no number in the front of the oxygen, so it's a 1. And we know that since the atoms are the same in oxygen, we write molecule to form, and you can see that there's 2 in front of the water. And again, since water is made of hydrogen and oxygen, we can write compound. You can see that in this drawing, I've drawn two sets of two black circles here, and so those are the hydrogens, and this one over here is the oxygen. So you can see that the ratio 2 to 1 is the same as in the reaction up here. So you know that you have to form two waters, and you can see that over here. That there's two waters being formed because the ratios have to be maintained. If I put two hydrogens in with two oxygens, it makes two waters. So let's look at our next example. Calcium. So we see that there's one calcium here, and since it's just by itself, we call it an atom. Reacts with, and we see that there's two of these AgCls, silver chloride, and since they're different, we call them compounds. To form, and we see that there's a 1 in front of the calcium chloride, so put a 1 there, and that's a compound because the atoms are different from each other. And you can see there's a 2 in front of the Ag, so you put two silver atoms. Okay, so again, you can see that there's one Ca right there, and there's two AgCls. And for the purpose of the activity, you'll find out here that since it's in the same proportion, there's one Ca to two AgCls, that you're going to get one CaCl2 and two Ags. We can see that the Cls are these circles with the X's in them, and the Ags are these empty circles. Again, the ratios are exactly correct because the ratios are exactly the same as what's in the given reaction, because on the reactant side, it was one calcium to two AgCls. If we double the Cas and we double the AgCls, we'd get double as much product. So, in the next example, we have a 1 in the front here. So we write a 1 sodium sulfide, and that's a compound. Reacts with, there's a 2 in front of this silver nitrogen oxygen compound called silver nitrate, and that's a compound because the atoms are different. We see that there's a 1 in front of the silver sulfide, the silver sulfur compound. That's a 1, and we write compound. And there's a 2 in front of the sodium nitrate, and that's also a compound. So we see here that I've actually made 2 NaS's, twice as many as expected, but this is the correct number of silver nitrates. What happens when you double something but you don't double the other thing? Well, that means that this is the limiting reactant. It's going to be used up, but one of these is not going to get used up, and you'll see that on this side. So you see here that this swirly thing that's inside this circle is supposed to be the sulfur, and that's over here. And we see that because the sodium sulfide compound was doubled, but the silver nitrate was not, we still only produce 1 Ag2S and 2 NaNO3s. And look, here's the leftover that came from that side. So this is the leftover, and these are the products. And so in our last example, we have 1 propane compound, because the atoms are different from each other, reacts with 5 oxygen molecules, because again, in oxygen, the atoms are all the same, and to form 4 water compounds, and 3 carbon dioxide compounds. Okay, so you can see in this example down here that there's 1 propane. It says that there's supposed to be 5 oxygen molecules. You can see here that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's twice as many. But since there's only 1 propane, you only need 5 oxygens. And so you will not get a doubling of the waters and the carbon dioxides produced. And you can see that over here. So you can see that there are 4 waters produced, 3 carbon dioxides produced, and you have these 5 oxygens that are left over because this is the excess reactant, the one that's left over, and does not help produce more product. So hopefully that's helpful for you to understand how to fill out the sentences and draw out the molecules, so to be able to understand what is limiting and what is excess. Thanks, and I'll see you in class.